Good afternoon, everyone. I will be discussing to you today the digital logic gates. Okay. So, what do we mean by digital logic gates? So, first we define logic gate. So, your logic gate, they are electronic circuit. Okay. Electronic circuit, and they have one or more inputs, and then they only yield one output. Okay, and then we have a logic circuit that is defined as a circuit that provides an input output relationship. Okay, that is expressed by the Boolean algebra. Okay, so mostly that is a circuit expressed mathematically in terms of Boolean expressions. So the next would be we'll be talking about binary logic. What is a binary logic? So we'll be taking two discrete values only. Okay, for this case, we have in our logic circuits, we'll be using 1 and 0. Okay, in terms of electronics or when we are implementing logic gates, that would be the difference between the high input and low input. Okay, or you have your high output or low output, or the logic 1 or logic 0. Okay, then we'll be talking about also the truth table. So, so what is a truth table? That is a Boolean operation table, which the values of 0 and 1 given to the variables are interpreted as true or false. Okay. Okay. So usually our truth table is expressed as in terms like this. So we have a table, then meron siyang label between the input and output. Okay. So this is your input, then this is your output. Okay. Okay. Now we proceed with the basic logic gates. Basic logic gates. Okay, first we will be talking about the buffer. Okay, that is the buffer gate. Okay, ito yung kanyang symbol. So that is it's like a symbol of an amplifier. Okay, and then we have one output only, and then we have one input. Okay, if we have a value, let's say the input is A, and it has an output of F. Okay, so the Boolean and then the expression, let's say expression here, or the mathematical expression of this buffer gate is, so we are taking functions in terms, we are taking the output F based on the input A. So this F is equals to A. So why we need a buffer, sir? Hindi ba pwedeng straight to wire na lang? Kasi gagastos pa tayo ng component. Okay. So your buffer class is a component that is used to isolate. Okay. Isolate two systems or two blocks in your electronic block diagram. Okay. And then, isa pa ang purpose niya is to match impedances. Okay. Okay. In your higher communications later on, that every electronics components or electronic uh, subsystems requires you to match their input and output impedances. So doon napasok ang ating buffer. So in your IC design, okay, so buffer gates is usually sold as the series. Okay, pag bibili ka ng IC class, mostly ang product code niya ay 7407. Okay. Okay. Bibili minsan that is 74 LS07. Okay, so minsan class ganyan ang configuration niya. Meron siyang letters sa gitna na mostly ang letters sa gitna class is an indication kung sino lang ang nag-manufacture sa kanya. Okay, then ang truth table nito class, truth table. Okay, so we have a truth table. We have, okay, so your input is A and your output is F. Okay, so F equals to A, so whatever your input yields the same output. So if you have 1, I mean you have 0, then output 0, then your input is 1, then you have an output of 1. Okay, so that is for your buffer gate. And then letter B, we have the NOT gate. NOT gate. Okay, so the symbol for NOT gate is a buffer gate na may bubble lang. Okay. And then this should be the output F. And then your NOT gate has also a one input, and let's call that as your input A. Okay, and then the truth table. Ang truth table nito is we have A and then we have F. Okay. Then we have two states because we are talking about binary logic. Then we have only 0 and 1. And then just inverse or complement the input. So you have 1 and then this one is 0. Then the expression of this one is F is equals to not A. Okay. Or complement. Okay, so we are talking about the prime, or you can also write as this one. But I preferred to write the prime symbol for NOT gate. And then for the IC, for the NOT gate, it is usually sold as 7432 in IC. 7432. Okay. Now we go to the next logic gate is the OR gate. Okay. Next is the OR gate. Okay. So your OR gate can be purchased commonly as 7432. Okay, 7432. Okay, okay. Oh, your NOT gate is mistake. The NOT gate. Okay, so your NOT gate is commonly sold as, this is not 7432, rather then it is 7404. Okay. Okay, sometimes the common term for your NOT gate is called the inverter, inverter gate. Okay. Okay. And then for the OR gate, it has a, this is its symbol. Okay, so OR gate, it has this one. So parang ano siya, parang curve. And then sharp. And then we have two inputs and two or more. So your OR gate class can be two or more input, pero hindi siya pwedeng maging one input lang. So you have an output of F, then you have A and B. Okay, for the truth table, so we have two inputs. Okay, so we have two puts, and then we have two states. Okay, only two states only. That is either one or zero. So the total combinations. Sorry, that is total combinations for the input is that is 2. Okay, so you have two states, then raised to two inputs. So you have four combinations of input. So we have input A, and then we have input B, and then we have F. Okay, okay. And then we have 0, and then 0, and then 0, 1, then 1, 0, and then 1, 1. Okay, so ang pattern nito class sa paglalagay sa truth table, yung first na ano, yung B, tingnan nyo, nag-alternate yung kanyang 0, 1, 0, 1. Tapos yung A, kada dalawang 0, kada dalawang 1, 0, 0, 1, 1. So later on, malalaman natin paano siya mag-plot ng truth table if yung input mo ay hindi lang dalawa, kundi 3 or more. So then F is, okay, so ang algebraic expression for OR gate class, ang equivalent ito sa mathematical ay parang A plus B. Okay. So A plus B, so that is 0 plus 0 is 0. Then 0 plus 1 is 1. And then 1 plus 0 is still 1. And 1 plus 1 is 1. Okay, class, we have talking Boolean expression. Okay, hindi yung katulad natin sa binary na 1 plus 1 is 0 carry 1. For this one, we'll be using the Boolean under sa logic gates natin that 1 plus 1 is considered as 1 only. Okay, so take note of this. So that is its truth table, and this one is its mathematical expression. Okay, or the Boolean expression. Okay, then the other one would be after ng OR gate natin, we have the AND gate. Okay. So what is an AND gate? Okay, so ang AND gate natin, ang IC niya ay nabibili natin as 7408. Okay. And its symbol is written as this one. Okay, so parang bullet. Okay. Then two inputs din siya, two or more, A or B. And then we have a output of F. Okay. And then ang Boolean expression niya is called as parang product or multiplication. So we have F is equals to A and B. Okay, so yun yung output niya. Okay, so kung i-construct natin yung truth table niya, so we have A, we have B, and we have F. Okay, so we have two inputs also again. So we have four combinations. So 0, 1, then 1, 0. I mean that is start pala tayo sa 0. Then 0, 1, then 1, 0, then 1, 1. Okay, then this is F. Okay, so that is parang multiplication. So 0 and 0, so yun yung pagkagabasa sa kanya. 0 and 0 is 0. 0 and 1 is 0. And then 1 and 0 is 0. Then 1 and 1 is 1. Okay. Okay. So yan yung kanyang truth table. Now, we go sa kanyang, meron tayong NOR gate. Okay, so letter E. So, i-ano na lang natin. Itabi na lang natin na hindi kasya. Okay, so we go with the OR gate. Okay, so we have the NOR gate. Okay, so ang NOR gate natin, ang NOR gate natin class has a symbol of, ano din siya, OR gate din siya, pero may bubble na siya class. Dito sa kanyang output, then this is F. And this one is input A and input B. And then we have the truth table. So ano to? Ano ang muna ang expression niya? That is F is equals to, okay, so i-complement lang natin yung output ng isang OR gate. So that is A plus B, then complement lang. Okay, so if we have a truth table, okay, so we have A, then we have B, and we have the output F. This one is 0, 0, then 0, 1, then 1, 0, and then 1, 1, 1. Okay, so the output is 0 plus 0 is 0, then complement, that becomes 1. Okay, then 0 plus 1, that is 1, complement equals 0. And then 1 plus 0, that is 1, then invert, you get 0. Then 1 plus 1 is equals to 1, then complement, it becomes 0. Okay, so that is its f, or the output of its function. Okay, and now let's try to check if what gate, or I mean ano kaya yung IC number. Okay, so the IC number for the logic NOR gate is the 7426. Okay, 7426. And I will be talking also to the different types of logic gates other than the basic logic gates that we had from the previous video. Now we have the another gate that is called as an NAND gate. So your NAND gate is actually an AND gate, that is yung output niya ay in-invert lang natin. Kaya kung mapapansin nyo, ang kanyang expression, that is katulad ng isang AND gate pero kinong-complement lang natin. Okay, kung ipa-plot natin yung kanyang truth table between input A and B and then output F, you will try to observe that is 0 times 0, it becomes 0. Kaso, i-complement nga siya natin yung output niya. So, that's why it becomes 1. Then, 0 times 1 is 0. Complement, that is 1. Okay, and then 1 times 0 is 0. Still, co-complement mo yung 0, it gives you 1. Okay, and then we have 1. And then we have another 1. So, 1 times 1 is 1 still. But, i-complement natin yung 1, which is become 0. Okay, so that is the truth table and the expressions by your NAND gate. Okay, so how about we have the XOR gate. So, meron tayong XOR gate class na may encounter din. Okay, ang XOR gate natin class, ang X niyan, it means that is exclusive or gate. Okay, so dinugtungan mo lang na exclusive yung OR gate. Ang symbol natin class niyan is katulad lang siya ng OR gate, pero meron lang siyang additional curved line dito. Okay, parang na-duplicate mo lang yung edge ng OR gate na to. So, yun yung tamang pag-drawing ng symbol niya. Ang expression niya class that is multiple. Ito yon. So, that is A and not B, or A and A not and B. Okay, so sometimes it is simplified as this one. Pero yan lang yung ibig niyang sabihin, yung taas na yun, kung i-expand mo ito. Ano yung class yung palatandaan niya sa ating truth table? That is XOR. XOR. So, ito yung class. Pag sinabi nating XOR gate class, any inputs na magkaparehas would become 0. Basta meron kang inputs na magkakaiba, yan ay logic 1. Ito, 2 inputs kasi ito class ha, 2 inputs to. So, ito yung pattern niya dyan sa 2 inputs. So, we have, tingnan nyo to, parehas, that's why 0. This one, parehas, that's why 0. Then, nagkaiba siya, then that is why 1 siya. Okay. So, that is an XOR gate. Then, another gate is a complemented version ng isang or XOR gate. So, yung tinatawag nating XNOR gate. So, that is an exclusive NOR gate. Mostly, ang IC niyan ay 724, 74265, 74266, and so on. Marami pa yan. Kaya ano itsura niya, class? Para siyang OR gate lang na meron lang siyang bubble sa unahan. Okay, so ang gagawin natin, di ba, pag may bubble sa unahan, i-invert lang natin whatever output ng XOR. Okay, so mapapansin nyo, di ba, ito yung ating expression sa XOR. So, ang ginawa natin, kinomplement lang siya. Okay, so pag kinomplement natin siya class, kung ipa-plot natin yung kanyang truth table, ay bakit siya andito? Okay, okay. Iusod ko na lang siya doon. That is F. Okay, kung ipa-plot natin class, yung truth table niya ay XOR lang siya. Complemented version lang siya ng XOR. So this one 0, this becomes 1, and then basta same 1, then ito ay different 0 para sa 2 inputs. Okay. Kung magkaroon na kayo ng 3 inputs class or 4 inputs, pag nag-evaluate kayo ng kanyang truth table class, then sundan nyo ang kanyang expansion. So, di ba, ito ay A, di ba ang or XOR gate natin ay A, tapos B not, then plus A not, then B. Okay. Then, inanat mo pa. Okay, so, ganyan ang kanyang expansion. Okay, so that is the additional logic gates nyo other than sa basics natin. So, just para mga derivatives lang ng mga basic or fundamental na logic gates. That's all. See you on the next video.